Let's make a quantitative LOL diagram, which means that we're going to need to calculate the values for all of our forms of energy and then make our bars accordingly. So let's do the first step, which is maybe read our problem, and then we will write the objects in our system. Then we'll start calculating. So Doug has a mass of 80 kilograms, and he's at the top of a 5-meter half pipe. We've seen problems like this before with Doug. He rolls down, and at the bottom of the half pipe, his height off of the ground is 0.5 meters, and he is moving at 9 meters per second. Okay, so let's see, I need a pen. So just a little doodle. So here's our half pipe. And here's Doug at the beginning. And then here's Doug at our second snapshot. Okay, so it was 3 meters, but now it's going to be 0.5 meters, and then he's moving at 9 meters per second. Okay, so let's write our objects in the system. We have Doug, we have the half pipe, which we know is rough, and then we have the earth, and I think that's it. So now let's start calculating. I have my formulas written up in the corner, but let's do just kind of a rough sketch of what our diagram is going to look like, and then we'll calculate. But I know that I'm going to start off with all of my energy as UG, and he's not moving at first. And then it's going to be some percentage of UG, some percentage of EK, and then some percentage of E therm. I don't know what it is. So let's do calculations. For the initial, that's going to be 80 kilograms times 9.8 times his height of 5. So if I put that in a calculator, that's going to be a big number, 3,920 joules stored in his height. However, when he's at the bottom of the half pipe, he only has 0.5 height, 0.5 meters of height, so that's going to be 80 times 9.8 times 0.5, so 1/10 of what we had before. So that's going to be 392 joules. So 1/10 of what it was before. Next, we want to calculate his kinetic energy when he's at the bottom. So we know his speed, so we could just plug it in. So it's 1/2 times the 80 kilograms times that 9 squared. And that's going to be 3,200, and that just looks silly. I need an eraser. 3,240 joules. Okay, and I do have E therm, but we'll come back to that. So I want to erase my bars and now like remake them according to our new scale. So I'm going to say this very top is 4,000 joules. Okay, so that means 3,920 should be, by my estimate, just below that. Okay, I want to use the same scale over here so it's easy to compare. So this top value is 4,000 joules. I'm going to have 3,240 for that EK. So if this is 2,000, then this is going to be 3,000, so a little bit above that. And then UG is going to be that 392, so less than 1,000, like a third of a way. So this is 1,000, 2,000, 3,000, 4,000. So only like not even halfway. All right, now here's the dilemma. I need to figure out what E therm is, but I don't know. I don't have a formula for E therm, but I do know that my energies over on the left have to equal my energies on the right. So I know that UG initial has to equal UG final plus EK plus E therm. You've seen this before. So that means if I want to find just E therm, I could subtract these two away from my original energy, and I should have my values. So if I take 3,920 joules and I subtract away the 392, and then I subtract away the 3,240, that's going to give me 288 joules. So I didn't lose much energy to thermal, even less than I have for the gravitational, and I'm trying to reflect that. Okay, so this would be what my final um, quantitative LOL diagram is. They're a little bit more intensive, but they do produce a better graph. It's better graphing skills. Okay, hopefully this has been helpful.